This is AP Precalculus notes for topic 3.13, trigonometry and polar coordinates. So in the past, what we've been using is what's known as a rectangular coordinate system, which I often call the Cartesian plane. The way that we typically move is in order to get to a point, we move left and right on the x-axis, and then we find the spot that we want, and then from there, we go up and down on the y-axis until we find our point. There are numerous ways of getting to the same point. One of them is the way that I just mentioned, using the Cartesian plane where you move right and then up, or left and then down. But sometimes you can simply see where you're looking. Before you're looking here at 0, you can rotate where you're looking at and then choose how far to walk in that direction or how far to move. So polar coordinates is change the angle from your standard angle of 0 by theta and then walk that certain distance amount. So the way that we say that is in the polar coordinate system, we have our point A, which we used to find by saying it was some x and then some y. But now we're going to say it's some radius of a circle or some distance after you rotate by theta degrees or theta radians. So again, the absolute value of r is usually what we refer to as the distance that you move. Yeah, you can get the same point many different ways. Let's try to see how you do that. Let's graph these, right? That'll be the best explanation. So I want to rotate pi over 3 and then go out a distance of 2. So pi over 3, it's labeled for us. So pi over 3 is this line right here, and I need to go out a distance of 2, which intersects right here. So my first point right here is A. Make sure you have these labeled as A, B, C, or D. Let's try another one. So this next one, I'm going to rotate to 3 pi over 2, and that's not labeled for us anymore, so you have to have that one memorized. Oh yeah, 3 pi over 2 is straight down, and I want to go out a distance of 1. So out a distance of 1 is going to live right here, and I'm going to label that point B. And before I move on too much further, let me remind you that each of these lines is pi over 12. That's 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, and 6 pi over 12. These two lines here and here are never used, which means if I was looking at this, I would always cross these off because we typically never use those. I've never seen them been used even in college level. All of these lines that I'm crossing off right now should never be used. I'm going to make a mistake and accidentally use those in the future. So I'm going to remind myself, don't do that. So 4 pi over 3. So 4 pi over 3, it might have lived right there, but I know that that line is crossed off. So this must be 4 pi over 3, and indeed it is. So this is 4 pi over 3, and I'm going to go out a distance of 3 on that line. So therefore I'm at this point right there because that distance, if I come back here, is indeed 3. And let's label that C. And then finally, we have negative pi over 6. So I'm going to rotate pi over 6 in the clockwise direction, and I'm going to go out a distance of 2 along this line. And then 2 is this distance right here. And there's my last point, D. All right, let's try another one. All right, so again, let's go pi over 4. So pi over 4 is this line right here, and go out a distance of 2. Going out a distance of 2 gives us point A. Now, this next one, I'm going to go negative 7 pi over 4. Okay, well, normally positive 7 pi over 4 would live right here. I'm going all of that distance around, which is kind of like saying go negative pi over 4. So I'm going to say actually go positive pi over 4. And okay, so that's actually the same point though, isn't it? So going negative 7 pi over 4 means I'm going to go all the way around like this, and I'm going out a distance of 2. That's the same point here. That's also point B. What about the next one? 9 pi over 4. Okay, well, that's too big. That's the same thing as saying 2 pi plus something. So 2 pi is the same thing as 8 pi over 4 plus 1 pi over 4. So this 8 pi over 4 is a full rotation, which we can ignore, and it's really just pi over 4. And again, go out a distance of 2. So pi over 4, go out a distance of 2, is the same point a third time. I have a prediction. I think the last point is also going to be point D. This point is going to be point D. Let's test 5 pi over 4. Oh, that's different. Okay, so 5 pi over 4, I go all the way to right here. This one is 5 pi over 4, and I go out a distance of what? Negative 2. Negative 2 means instead of going out this direction, I go a negative direction, and yet again, I am on the same point. I called it. So you can see there are many different ways of getting the same point using a bunch of different answers. So this is different though, right? In the Cartesian plane, when we just had an x and y axis and it was rectangular coordinates, there's only one way of getting to the right answer. There's no tricky business, but now there is tricky business. You can go ahead and give an infinite number of ways to get to the same point. So let's try that. Can you, I thought we were going to do that. Oh yeah, so we're going to do that right now. 3 and 5 pi over 6. So we're going to first plot that and find 2 additional ways that we can try to do that. So 5 pi over 6 lives, it's not, I was going to say that one, but we don't use that one. 5 pi over 6 is this one, and I come out a distance of 3. So it's this point right here. And I'm just going, I don't have a name for you. Maybe it's Bobette. And then I want to find new different ways of writing that. So I like the way of going this direction over here and then doing a negative answer. So this angle right here is 11 pi over 6. So I'm going to say my first answer is going to be I rotate 11 pi over 6. And then instead of going a positive 3, I'm going to go a negative 3 and go backwards. So negative 3. That's a cool way of doing it. Let's do another one. Let's rotate... instead of rotating clockwise here, let's just rotate counterclockwise. If I wrote counterclockwise, here's a whole pi, and then another pi over 6 more means I've gone 7 pi over 6, so negative 7 pi over 6. So, whoa. So if I go to a negative 7 pi over 6, and then I go out a distance of 3, that will get to the same point. You could have also just added another loop. Let me give, I'm an overachiever. Let's give a third one here. Ready? I'm going to go a distance of 3, but instead of doing this dinky little 5 pi over 6, let me go here and then all the way around to back here. So I'm going to add on a full rotation. So if I do that, that means I'm going to have a 5 pi over 6, and I'm just going to add on another 2 pi, which is the same thing as saying 5 pi over 6 plus 12 pi over 6. So 5 plus 12 is 17. So I went 17 pi over 6 rotations around. So 3 different ways. You can choose any 2 for your notes. All right. So you can connect these, right? If I overlay this graph on this graph, I get this graph. I get a triangle. So I can easily see a way to get between polar and rectangular form. So if I have an answer out here and I'm trying to get to rectangular form, I can say, well, I happen to know that I'm just going to undo our theta using tangent. I'm going to undo our radius by using x and y definitions. So what are those definitions? You ask, well, check it out. Watch this. So from our original definition, cosine is x divided by the radius, and sine is going to be y divided by the radius. So if I want to solve for the radius, I can, solve for x and solve for y, because those are the things that we want, right? If I want to solve for x, I need to undo dividing by r. So I'm going to multiply both sides by r, and r times cosine of theta gives me x. Same thing, y is r times sine of theta. So I can find x and y by just doing those 2 formulas. So 2 formulas that are super easy to memorize, that will 100% always get you to rectangular form from polar form. But if you're doing the reverse, it's a little bit tricky, and we'll talk about that in a sec. So how do we convert these? Just use the formulas is the easiest way of saying this. So you can say, x is going to be equal to r cosine of theta. Okay, well, what is r? This, by the way, it goes r and then it goes theta, right? So r is 2. So we can say x here is 2 times cosine of theta, and cosine of theta is cosine of pi now. And okay, so I have to, this is what I'm doing in my head, right? I'm saying, okay, where does pi live? Pi lives right over there. So that's just, I'm going, in terms of an x direction, I'm just going -1. Cosine of pi is -1. I can say this is the same thing as 2 times -1, which is just -2. Okay, I have the x coordinate. I have half of the answer. I need a y coordinate. So how do I find the y coordinate? Use the formula. Y is equal to r sine of theta. Okay, here we go. R is 2, and then I do times sine of pi. Okay, so pi again is this direction right here. So sine is how much up and down I've gone. Well, I haven't gone any, so sine of pi is 0. And 0 times 2 is 0. So my coordinates here are going to be x comma y, or -2 comma 0. And there's my final answer. Let's try another one. Let's try this one. So again, use a formula. To find x, it's going to be r times cosine of theta. So what is r? R is 4. Our theta is 5 pi over 3. So this is going to be equal to 4 times cosine of 5 pi over 3. You probably already have these memorized, but just in case you haven't, 5 pi over 3 lives right here. Cosine is how much left and right you move. I've moved a small amount to the right, which means this evaluates as +1/2. So this is going to be equal to 4 times 1/2, and 4 times 1/2 is 2. halfway there. We have the x-coordinate. Let's find the y-coordinate. The y-coordinate is r times sine of theta. R sine of theta. Here we go. R is 4, and then theta is 5 pi over 3. So sine of 5 pi over 3, sine is the y-coordinate of how much down did I go? Well, I went down a large amount to get all the way down here. Down a large amount is negative square root of 3 over 2. So there's going to be 4 times that negative square root of 3 over 2. And I'm seeing that this 4 and this 2 are going to kind of cross cancel. And this one's going to turn into a 2. This one's just going to go away. And that means this is going to turn into a negative 2 root 3. And therefore, our final answer here is going to be x comma y. X is 2. Y is negative 2 square root of 3 for our final answer, which I will then box. And I should be checking my work. Looks like I got it. And then let's try another one. C. So again, use the formula. So I can say x here is equal to r times cosine of theta. Therefore, x is going to be equal to negative 3 times cosine of 7 pi over 6. All right, 7 pi over 6, where do you live? 7 pi over 6 lives right about there. So you're coming down just a wee bit. Cosine is the x-coordinate, so I'm going left a large amount. So left square root of 3 over 2, or negative square root of 3 over 2. So it's going to be negative 3 times negative square root of 3 over 2. A negative times a negative is a positive, and this is going to be a positive 3 root 3 over 2 then. What about for a y-coordinate? A y-coordinate comes from the formula. It's r times sine of theta. And r in this case is negative 3 times sine of 7 pi over 6. Okay, where's 7 pi over 6? I already have it up here. 7 pi over 6 lives right here. Sine is how much up and down I've moved. I've moved down this small amount. If I move down a small amount, that's down a half. Down a half is negative a half. So this is going to be negative 3 times negative a half. A negative times a negative is a positive, and this is just 3 halves. So my final answer here is going to be 3 root 3 over 2, which is the x-coordinate. There we go. 3 root 3 over 2, comma the y-coordinate, 3 halves. Done and done. And I should box my final answer, x and y coordinate. All right, let's try going the other direction. So the other direction is arguably more work because you have to use 2 things that both require a bit of work. It's not just one formula. So the first formula is Pythagorean theorem, which is x squared plus y squared is equal to your radius squared. So leg squared plus leg squared is equal to hypotenuse squared. And then you can solve to figure out what the r is. Because what you're after for an r and you're after a theta. So to find the theta, you set up a trig expression that has both your x and your y, which you should have been given, right? Because you're given your rectangular coordinates of x and y. So you plug it in into this fraction where it's y over x. Again, think about slope, right? Slope is always y over x. And then to undo tangent, you take the arc tangent of both sides. So really what I would add to this, I would say, okay, I'm taking the arc tangent of this left-hand side. I'm taking the arc tangent of this right-hand side, and you'll notice that these arc tangents and tangents cancel out, and you can figure out what your theta is. Your theta is just arc tangent of y over x, and that's usually the shortcut that everyone always uses. I'm kind of confused why that wasn't listed up here, but whatever. Okay, so let's show you how to do that. We're after a radius, and we're after a theta. So first comes our radius. So again, Pythagorean theorem, you're going to do one of these numbers squared plus the other number squared, and that's going to be equal to your radius squared. So expand this out. 4 plus 4 is equal to your radius squared. 8 is equal to your radius squared, and therefore if we square root both sides, technically it's plus or minus 8 is equal to your radius, but let's go ahead and just assume that's the positive because we're supposed to be in positive units. So I'm just going to say the square root of 8 and call it good. Although the square root of 8 can be reduced to technically it's going to be, let's see, a factor tree of root 4 and root 2 to 2 square root of 2, but I guess it's fine. I don't know. It depends on what the multiple choice is. These are very typically multiple choice type questions. They'll probably put that, but they might put that as well. Be ready for both of them. Okay, so we're halfway done. We found the radius. We also need to find the theta. We need to find the angle, which means you guys need to move over and leave some room to find our theta. To find our theta, I know that I'm going to set up a tangent. So tangent of theta will be equal to the y-coordinate. Again, y-coordinate is that one, so it's going to be 2 divided by the x-coordinate, which is negative 2. And that's like saying, hey, tangent of theta is equal to negative 1. Well, where does that happen on a unit circle? So this is where you draw yourself a mini circle and you say, okay, tangent of negative 1, that means I have a slope of negative 1. A slope of negative 1 looks like this. So I can either have that point there or that point right there. Technically speaking, arctangent only lives on the right-hand side, and it's really that point right there. But I guess any of these points would technically work. I think I'm doing this problem right. Yeah, okay, so let's just go ahead and call it that point right there, which is negative pi over 4. So we can say that that's negative pi over 4 right there. And therefore I can say, did it tell us? It didn't say we had to be positive or negative. So I think we're okay. I guess I could have also gone up here to 3 pi over 4. It doesn't really matter for this one. I'm going to stick with my intuition. It should be negative pi over 4. So the answer here should be 2 root 2 comma negative pi over 4. Ta-da. Oh, wait, that doesn't work. I see why it doesn't work. Look, where is this thing? And what I was assuming domain restrictions for arctangent is always on the right-hand side. But look, this thing is in go left, then up. If I go left and then up, I'm talking about that point right there. So you, my friend, are wrong. Let's go to 3 pi over 4. So the one thing I'm forgetting that you should not forget, learn from my mistake, which is check where we were supposed to be. We were supposed to be in quadrant 2. Quadrant 2 is up here. Therefore, it had to be that point of 3 pi over 4. All right, let's try another one. B. So again, Pythagorean theorem, so I'm going to say 1 squared plus the square root. Technically, it's negative. I'll do, what am I doing? Square root. Yeah, so it's going to be negative square root of 3. That entire thing squared is going to be equal to my radius squared. Just stick whatever you got. This is a whole negative. Stick it right there and then square it. You don't really have to worry about the signs because if everything is being squared and you're not dealing with the shadow dimension of complex numbers where you have imaginaries and stuff, you don't have to really worry about it. And of course, this lesson does have that at the very end. So maybe I should be careful there. But 1 squared is 1. Square root of 3 squared, again, they kind of cross cancel, right? Square and square root undo each other. And whenever I square a negative, it becomes positive. This is just a positive 3 plus 3. And that's equal to my radius squared. 1 plus 3 is 4. So 4 is equal to the radius squared. And if I square root that, I get plus or minus 2. We'll just keep everything nice and in positive units. So the radius is 2 here. So my final answer is going to live right there. It's something, comma, something. I know that's the radius, comma, my angle theta right here. So to find theta, I'm going to say that is equal to, well, tangent of theta will be equal to my y over my x, my negative square root of 3 over my x coordinate of 1. Oh, that's just negative 3. Okay, so I can kind of ignore that. So this is a large number for a tangent, right? So if I'm looking at a unit circle, a large number means I have a really large slope, and it's a large negative slope. So a large negative slope looks like that. So again, I could be that point there or that point there. Let's learn from the lesson last time. Where are we? We're going right and then down. If I'm going right and then down, I'm talking about this point down here in quadrant 4. So it's that point right there. And I could go negative pi over 3, or I could go all the way around to 5 pi over 3. It doesn't really matter. There's an infinite number of answers there. I'm feeling positive. 5 pi over 3. So that means 5 pi over 3 goes here. Done and done. Box it. Did I box my last one? I did not. All right, box that one. All right, last question of the notes. I don't think there's, and then after this, oh no, we have more notes after this. I am wrong. All right, what do we have here? This is going to be 0 squared plus negative 5 quantity squared, and that's equal to my radius squared. Last I checked, this is going to be 25, which is equal to our radius squared, and square both sides, and that's going to give us 5 for our radius, which makes sense because if this is some distance, the radius is the distance. I haven't moved, and then I've moved. I've moved 5, I've moved 5. Okay, so the radius is 5. My final answer is going to be down here. It's going to be 5 in some direction. And just logically speaking, like, where is this thing, right? You don't even need to really do inverse trig, but I will in a sec. If I'm going 0 to the right and to the left, I'm just going down 5. Going down 5 means I'm at 3 pi over 2. But let's say you didn't know that and you do it a different way. If you're doing it a different way, you do this. You'd say, yes, tangent of my angle theta is equal to the y coordinate divided by the x coordinate. Oh, it's undefined. Where does undefined happen on this unit circle? Undefined means I have a slope that goes straight up and straight down, meaning it's either this point or this point. Which one is it? Well, I'm going down 5, so it's that point down there, which is also known as 3 pi over 2, which is I already said at the very beginning. 3 pi over 2. Done and done. Box it though. Box, box, box. All right, onward. Oh yeah, so complex numbers. So the complex numbers, I think you guys might have seen this before, and if not, then it's super easy. Basically, instead of saying this is 3 comma 2, you will instead now say it's 3 plus 2i, where the up and down axis, instead of being the y-axis, it's no longer the y-axis, it's the imaginary axis. It's really the shadow axis. That's a cooler name, but whatever. It never took hold. So this is called the imaginary axis, and this is the real axis. So they're not labeled down here, so let me label them for you. This is the real axis, and let me turn my iPad sideways so it looks like I have fancy handwriting from the side. Imaginary. Usually we just say I. These are units of I. How much is the imaginary building block? Well, the real building block is 1, plus another one is 2, plus another one is 3. The imaginary building block is I. So this is 1i, 2i, 3i, 4i, etc., etc. So this point here, you go 3 to the right and then 1 up. So it's kind of like the coordinates 3 comma 2, but now we just say 3 plus 2i. There's no parentheses and there is a plus or a minus sign in between. It's a minus sign if you're going down. For another example, if you just randomly came down here, you'd go left 4, so you'd say minus 4, and then I'm going to go down 2, so minus 2i, and that is the way that we'd say that complex number. Complex is just anything that lives in the complex plane, which technically I think almost all numbers do that you deal with in high school. So yes, it says 3 plus 2i is the same thing as the point 3 comma 2 with rectangular coordinate system. So we can still use these older definitions. Hey, we know that x is equal to r cosine of theta and y is equal to r sine of theta, which means, and if I want to convert this thing, I just need to put an I in front of my y term and I'm done. And that's exactly what they do. They put an I in front of this y term right here and they call it a day. It's the r cosine of theta, r sine of theta, but they put an I in front and suddenly it becomes imaginary and complex, and it's trivial, but it's useful. So let's go ahead and show how I do that. I have the coordinates -2, -2, which on my plane lives like right here. So obviously I know that the answer here is -2 minus 2i. That's not what it's asking me to do. It's asking me do that using r and theta, which is the equivalent of saying ignore all of the imaginary stuff. They want us to write it like this because this is the way that you're supposed to write things. But how do we do that? So again, we need to figure out what angle have I rotated by? What is this angle theta right here? And how far have I gone? Well, I've gone a little bit more than 2 and a little bit less than 3. How do we find that? It's the same thing as before, where we say, hey, to find the radius, you do Pythagorean theorem. We say -2 squared plus the other -2 squared is equal to our radius squared, and we've done this before. 4 plus 4 is equal to the radius squared, therefore 8 is equal to the radius squared, and therefore we square both sides and the radius is equal to the square root of 8. And if you want to go a little bit further, you can say that's the same thing as 2 root 2, but again, most people just say that's the square root of 8, which is a little bit less than the square root of 9, so this number is a little bit less than 3. So we have the radius, check. We need theta. So to find our angle, we say that tangent of that angle, theta, is equal to the y-coordinate divided by the x-coordinate. Well, the y-coordinate is -2 and the x-coordinate is -2. Therefore, I'm essentially saying, where do we have a tangent where we're equal to 1? And then to answer that, you go to the unit circle and you say, okay, there's my unit circle. I need a slope of +1. Ta-da, it's either there or it's there. Which one is it? Well, I'm going left and down. If I'm going left and down, I'm talking about that point right there using positive angles and not negative angles. This is also known as 5 pi over 4. You could also say it's -3 pi over 4 if you're cool like that, but I'm going to use 5 pi over 4. So there's kind of our answer. So you can't just say it this way though. So I'll say what most people do. They'll say like it's the square root of 8 comma 5 pi over 4. I mean, you're kind of right, but because this is in complex land, because we're on the complex coordinate plane where we have an imaginary axis and a real axis, the way we actually answer it is like this. We say, okay, use those, but I want it in this form. This is the form of complex numbers. So you'd say, okay, you have to write the square root of 8 twice. And my handwriting has suddenly become terrible. So I can see everything. I'm going to say the square root of 8 times cosine of my angle. My angle's 5 pi over 4 plus I times the rest of this again. Square root of 8 times sine of my same angle, 5 pi over 4. It's super duper inefficient to write it this way. That's why we've invented better ways of writing it, like using Euler's form. But whatever, that's what they want. That's the answer. We can box it. I don't like this form because you have to write the square root of 8 twice. You have to write this 5 pi over 4 twice. You have to write cosine. You have to write sine. This would be much easier, but whatever. That's what they want. Same thing again down here, going in reverse. Now they're saying, hey, we're giving you this form. And notice the I. We're in complex land. We're talking about that shadow system of complex numbers. Where is this thing? And use rectangular coordinates. Don't even use an imaginary unit. Where does this thing live? So again, convert it. And the cool thing, the nice thing about this form is this is the x coordinate. That is the y coordinate. Ignore the I and you're kind of done. So what is this? First, I'm going to evaluate what cosine of 7 pi over 6 is. And I need to look at, and this is what's going on in my head, right? 7 pi over 6 lives right there. If that's, and let me label that so you can see, 7 pi over 6. If that's 7 pi over 6, cosine is how much left we've moved. We've moved left a large amount. Large in terms of a cosine is square root of 3 over 2. So this says 4 times negative square root of 3 over 2. Why negative? Because we moved to the left. Left is negative, right is positive. So multiply those together, and that's technically 4 over 1. The 4 and 2 will cross cancel. Let's do that in a different color. That's going to turn into 2. You're gone, and I have negative 2 root 3. That is literally the x coordinate, and we are done with the first half, and I can just do the second half. The second half is do the same thing again with sine. So this is going to say 4 times, okay, what is sine of 7 pi over 6? 7 pi over 6 lives right here. Sine is the y coordinate. How much down have you moved? I've moved down a small amount. Small in terms of sine means it's a square root of, or sorry, it's a 1 over 2. So 1 over 2 down is negative 1 over 2. 4 times negative half is negative 2. And there's my final answer. It's negative 2 root 3, comma negative 2. And I can box it. Ta-da! And I believe that does now finish, yeah, that does now finish the notes. So there's the last page, second to last page, second page. Oh, now that was the third page. This is the second page, and there's the first page. Thanks for watching.